Hello everyone and welcome back to another book review. Today I have another math book that I'm going to be reviewing. This is a book that I read and I loved and I spent a lot of time just getting into the details of the book, and I hope that you find this book as enjoyable as I did. I am, of course, talking about Euler's Gem, the Polyhedron Formula, and the Birth of Topology by David S. Richeson. So I am only going to be showing things from the inside of the book. That is because I ordered this book from another library, so my personal information is on the front cover. So that sometimes happens because I am a library reader. I don't necessarily own every single book that I review. So this book, I was intrigued because it had the word topology. Topology is a field that I was introduced in my college math courses, but I never took a proper topology course. And I was intrigued at how this book might present the topic and what I could learn from this book. And I actually wound up really liking it because I think the author had the right idea when going into this maybe more complex topic by starting with a very simple formula. And that is the title of the book, Euler's Gem. He's referring to Euler's Polyhedron Formula. So if you're thinking right away, this is too much math for me, I'm not interested, I actually really like the approach the author took because he uses a very simple and basic formula that's easy to comprehend with very basic middle school, high school mathematic background, and able to go into a very complex but rather interesting topic in math. So I'm just going to start by reviewing what the Euler Polyhedron Formula is. This was something that was introduced to me in college, but I believe I actually was introduced to it in high school, but seeing how it was applied to topology made me think about this formula in a whole new light. So the Euler's Polyhedron Formula, and this applies to convex polyhedron, so not things that have dents or have a concave section, and that is for these convex polyhedron, vertices minus edges plus faces equals 2. So this is on page 2 in the book. We start very early. And what I like about the approach the author took in Euler's Gem is he's going into topology, a subject many people don't study unless they've had advanced formal math education, with a very easy to understand formula. This is a formula that only has the addition sign, the subtraction sign, the equal sign, and with a little review of geometry, you will be able to recall what a vertex is, or what a vertex is, what an edge is, and what a face is on a polyhedron. So this is something that's completely within grasp of anybody who had any sort of math education, probably through middle school. It's really a basic formula. And he uses this formula, and he mentions this in the preface, to go through the field of topology. And if you're still wondering what topology is, I will get to that in a minute. But I first wanted to talk about my personal experience with math, and that is, for me, math gets interesting at the college level. So I do have a degree in math. I have my bachelor's, my 4-year degree in mathematics, but for me, math didn't get interesting until I started taking calculus classes in high school. That's where it became intriguing, and it truly became interesting in college. And I think the sad part is many people drop out of math education or learning about math before they even hit, in my personal opinion, the more interesting topics in math. Some of the more interesting classes I started taking in college and realizing that maybe this was a field I wanted to study full time included topics such as discrete mathematics, or my favorite of all time, abstract algebra. The proofs got me, but it was a fun class. And topology is one of those topics that I think is something that could be of interest to a lot of people. So because, again, I never took a formal class, I am going to read the Wikipedia definition of topology just to make sure I'm being accurate. And in mathematics, topology is concerned with properties of geometric objects that are preserved under continuous deformations, such as stretching, twisting, crumpling, bending. So basically, when you have an object, and the classic example is if it's made out of rubber, can you deform it without cutting any holes in it or re-gluing or attaching and make it be the same object? The classic example is a coffee cup turning into a donut, which is called a torus. And the Wikipedia page, if you happen to go on it, has the good example here. It shows how the coffee cup deforms into a torus, and they also have this example of a holeless cow. Cows have holes in real life, but a holeless cow being deformed into a sphere. So in topology, these topics, or these shapes like the coffee cup to the torus, are considered homeomorphic because they can change into one another without being cut or glued. Of course, that's a very entry level, and as you can imagine, it gets quite complex from there. But ideas like that I feel like would be very interesting to introduce to a 9th, 10th grade audience to show them that math is a lot more interesting than maybe what you're experiencing in K through 12 education, but you need the foundation of K through 12 to be able to study and appreciate. And what I like about this book is that the author takes a formula, Euler's Polyhedron Formula, which is easy to understand, only has very basic, there's no weird symbols, you're not seeing something that you hadn't encountered by the time you left 5th grade in elementary school. You have addition, subtraction, and an equal sign, but between all of that, you're able to explore this field. The author does talk at the very beginning, and I'm going to just read this section from the preface because he explains who his audience is and who he thinks the book is for in words that, instead of just paraphrasing, I'm going to quote. So this is from the preface, and he says, "This book has no formal prerequisites. The mathematics that a student learns in a typical high school mathematics sequence, algebra, trigonometry, geometry, is sufficient, but most of it is irrelevant to this discussion. The book is self-contained, so in the rare cases that I need to, I will remind the reader of facts from these mathematics courses." And I like that section right there because he's saying that if you want to dive into this topic that you probably didn't experience in your K through 12 education or whatever the numbers are in your schooling system, you have the opportunity to do this in this book. He's starting with a very basic assumption of your knowledge of mathematics and going into an interesting topic. He also goes on to say a little bit later, "Don't be misled though, some of the ideas are quite sophisticated, abstract, and challenging to visualize." There's a lot of stuff in here about the 4th dimension. I will say the author does a really good job about including different diagrams and drawings which help in understanding or visualizing what you are saying. But he warns the reader should be willing to read through logical arguments and think abstractly. Reading mathematics is not like reading a novel. The reader should be prepared to stop and ponder each sentence on its own. Basically, he's warning you that you can't just sit and read this like a novel unless I suppose you've had very advanced mathematical training at maybe a graduate level. I have a 4-year degree in math, and I still took quite a bit of time to ponder and read through this book. He does say, though, if a particular thorny argument is too difficult to grasp, jump to the next topic. Doing so will not sabotage the rest of the book. And the author does a really good job of covering a wide range of topics, not only getting into topology, he also goes into, and he does this in a more or less chronological order. So we're talking about Plato's atomic theory, Euclid's and his elements. Then we go through individuals like Kepler, Euler, Descartes, I hope I'm saying his name correctly, the Königsberg bridge problem, which I believe was also a precursor to graph theory, which is another field of mathematics. And then we have things like the 4-color map problem. We go through knot theory, which is, knot theory, which is another interesting branch of mathematics. We have combing the hair on a coconut, which is if you have a sphere, can you make all hair, if there's hair growing on it, lay flat? And then we have topology controlling geometry. So we're learning about how geometry, a field that's familiar to us from our K through 12 education, relates to topology, a field that we've been introduced to in this book. Also discussing higher dimensions, n dimensions, so dimensions beyond the 3 dimensions that we are familiar with. And of course, the Poincare conjecture as well, which has of course been solved by Gregory Perelman, or he's the one who's normally credited with it. So he did solve it. He was awarded it, but I believe, now I'm just going off script here, but I believe he built extensively on the work of previous people. There was a lot of work leading up to the solving of the Poincare conjecture is what I'm trying to say. But Gregory Perelman is credited with having the correct solution to that problem. And what I think the beauty of this book is as he says, there's no test, you can skip over topics, but it's giving someone a very basic formula that anyone can understand and allowing them to explore topics in mathematics that they haven't always, or they haven't probably been exposed to if they didn't take math at a college level. And I like that because I think there's a lot of mathematics that the public isn't exposed to that they would really enjoy if they just had the opportunity to be exposed to it. And that's why I really like this book and I really highly recommend. The author does say in the preface too, "It is my belief that the audience for this book is self-selecting. Anyone who wants to read it should be able to read it. The book is not for everyone, but those who would not understand and appreciate the mathematics are precisely those who never pick it up in the first place." And I will say that if you had the patience to click on a book review for a book that had the words Euler's gem, the Polyhedron Formula, and the Birth of Topology, you probably have the patience to sit and reason through this. Now, I'm not going to lie, as mentioned before, this book does take a little bit of thought. So I really enjoy reading and reviewing math books, but especially a book like this just requires a little bit more thought and effort to put into this. I can't just sit down on a sunny Sunday afternoon and spend a couple hours reading this book. A book like this does require a little bit of thought, but it's the process of, if you want to, if this is a field that you'd love to be introduced to, the author takes, in my opinion, is kind of a complex topic of study or field of study and gives it in a way that is accessible to someone who just has a high school education. And I think that ability to communicate a more complex subject to an intermediate or not as advanced audience is a skill, is definitely a skill set, and I think the author has it. I'd say don't be discouraged. Even I, with a 4-year degree in math, although to be fair, it's been like a few years since I've graduated college, I had to sit and reread some subjects, and there were some parts in here that I was like, we're just going to look up this later, or I'm going to be looking into this later, because this book really did inspire me to continue learning about topology. However, there are some parts in here that were thorny and tricky for me to work through. So I say don't be discouraged, but if you have the interest, it's something that is accessible to you. So you don't need to have a 4-year degree in mathematics. You don't need to have any specialized or formalized training. This book will walk you through the field of topology and introduce you to this interesting, cool world where toruses are considered homeomorphic to a coffee cup. And if this sounds interesting to you, I think Euler's gem, The Polyhedron Formula and the Birth of Topology, again by David Richeson, is a great book for you and a great book for you to check out and read. If you've read this book or have any other books on topology that you would like to recommend, please leave it in the comment sections below. I love to receive your comments as always. Thank you so much for all the support that you've shown, and I hope that you have a great rest of your day.